Hello, I'm back again. Right, I've been dying to get back to this. Um, yesterday I was sort of busy doing some other stuff. I did do a little bit of coding, but I've been trying to work on, consistent bit of work on the stream, just to kind of have that continuity, and then just working on other bits and pieces to kind of support that. If I get a little bit of time here and there. So let's see where I'm at. Um oh yeah. What I was doing, I did add a teapot mesh for fun, and had to do a bit of modification to get that to look nice. And I think that's oh no, I finished I wrapped up these ones as well, which are like prisms which can have a kind of inset. They're actually the same as these tubes, they just have smooth normals. So that's cool, but that's what I've been working on the side. But more importantly, here is the material system working with bindless texture lookups and bindless material lookups. In the end, I was pretty close on the end of the stream last time, and I was pretty annoyed about not being able to get this working. But I'll go through kind of what the problem was. So when you bind a shader, or bind a texture or shader resource view types on the same register. So in the shader, there is all of these textures are bound on T0. These structured buffer is also bound on T0. And then this one's bound on T0 space 1, because what I discovered is entities and materials can't alias the same register. And then I had some code which can look up based on these bindings, which slot in the descriptor set it needs to be bound on. And that was actually incorrect. So what was happening, it was trying to bind on a slot that didn't exist, and it was causing a crash, or it wasn't binding the thing at all. And then it was looking up inside an array that wasn't bound on a heap. So that's working now, and it's sort of I've tidied up my utility function. The way this is working, so these can be ignored because they're in this file, but they're used on in other shaders, so they kind of get compiled out. But these are the way it's working at the moment. So we have entities and materials, which are two different kinds of structured buffers on T0. This is T0 space 0, T0 space 1. So then we bind the heap on this, which is slot 0. And then we bind the textures on slot 1. So, or register 1. I might have a little look into that a bit more in detail in the docs, but I got it working very quickly after the stream. So the stream, because the GPU was crashing all the time, that was quite disruptive. I think it actually made the audio and video go out of sync and stuff like that. So when I'd stopped, I was just able to regroup and get this working. So that's working. Another thing I'm doing now, which I don't really have any way of demonstrating, is when I switch between these samples, the textures get reloaded, say on the draw material. You can see it coming out here. These are loading images. It's a little bit too long. I wish the text was smaller, but this is the size of the text to make it more readable on the screen. But what was happening before is they were being allocated. The resources themselves were being dropped, but the resource views were not being cleaned up. So if you loaded in and out of the sample many times, you would eventually run out of space in the heap. So I've bitten the bullet and I've gone for something that I wasn't super keen on doing in the first place, but I implemented a drop for a texture and drop for a buffer. And this uses a free list, which is an arc mutex. And I've tried to refrain from just making everything arc mutexes. all around the code base. So instead, they keep a hold of a free list, which is just a vec inside a mutex. And then if we have a free list, the idea is maybe you might want to disable this tracking because you can handle it yourself. And there's some stuff I've been working on that I'll also talk about, which kind of makes that a bit more viable. So if you have a free list, we check if you've got shader resource views, unordered access views, this resolved SRVs, so you can have an MSAA texture always to resolve into if you've got an MSAA surface, render target views, and so on. And they are just part of a free list, and a free list is part of a heap, and the heap has also a reference to a free list. So there's a bit of reference counting, thread safety, and stuff that I've tried to refrain from just throwing that everywhere. And here it felt like it made the most sense, because even though you might know what you're doing, it's really easy for you as a user. If you want to add a texture component, you have to then remember to clean that up at the end. We have to remember to, if you're going to throw things away, to drop them in a safe way. And that's currently be handled when you swap samples. We wait for the last frame on the GPU to be flushed, and then we can throw everything away safely. So you can use those sort of conventions to know what you're doing. So that's kind of one thing where I'll write up a blog about this and these sort of recent developments, because I actually said in my previous post I was trying to refrain from doing that. And I also have create texture with heaps, so you can pass in a texture heap info, and that has a shader heap, a render target heap, and a depth stencil heap, which are all optional. So that means what I can do now is PMFX, the higher level rendering system, creates its own heaps for resources. And that makes it viable. We could say, I don't want to... Oh, I'm in the wrong place. You say, I don't want to do all of this, like, tracking and cleaning up in the drop, because what I'm going to do is load into a new sample, and I'm going to throw away, and I'm going to completely clear the heap anyway. And so you get that flexibility. So I need to make this maybe enable on a feature. But for the time being, I'm using it to great effect. I think I'm possibly leaking buffers now, but I already had create buffer with heap. So you have the flexibility to do that. You can create heaps, and you can create resources on those heaps. So now, what do I have? Texture 3D. That's a signed distance field. And oh, if you go inside it, it's it doesn't render, but that's fine. Signed distance field, that's loaded, created on a heap. Cube map, created on a heap, and all the heaps are bound. So that makes it a bit better, and that also means I've been able to refactor some of the rendering code a little bit. Basically, all these render functions were being passed in a device and PMFX and other stuff. So then the device was unused in quite a lot of them. So now they just get past PMFX, and I think it's this one. Yep, we have PMFX shader heap. So the shader heap is actually called descriptor heap. I've been calling it shader heap. It's things you sample, it's shader resource views of textures, buffers, or unordered access views, and constant buffer views. So it's basically any heap that's not a render target heap, or a depth stencil heap, or a query heap. There might be more heaps, but they're the ones I've got at the moment. So anyway, that's what I've been doing. I've been just cleaning that up, and then I'm going to just check my to-dos in the other workspace and just see if there's anything else that I've done in the meantime I already talked about that. I flipped the UVs on the geometry, cleaning up the SRVs in the ECS world. That was basically it. It was a fair amount of work. I tried some other stuff originally, some like unsafe kind of code, and in the end I did that, and I thought I may as well at this point just make it thread safe. So it's arc, it's mutex, and at the moment that's for convenience. I think it could be improved, but that's where I'm at the moment, and I'm fairly happy with that, to be honest. So with that in mind, what I was sort of starting to think about now is the material system is coming along nicely. We've got materials here. I could sample from the normal maps as well now if I wanted to. Let's do that for fun just while I'm here. So let's see. We've got the material shader. We're bringing in textures debug. I'm not going to rock the boat. Textures debug is still a bit debug, and that I want to sort of investigate about the register spaces and things like that a little bit more. I don't need that code anymore actually, but we're using textures debug, and if I change the IDs to 1, this should change them all to their normal map versions. Cool. So it should be the corresponding normal maps. And if I change it to IDs 2, this is all of their roughness maps. So these are kind of like ready to go, right? I've got the maps. I can texture stuff. What next? Well, a little detour. I mean, and this sort of sounds like a philosophical question. Like how does a material exist without lighting? So basically I'm going to need some lights to make these actually work. I need lights and roughness and a BRDF, or is it BDRF? Bidirectional reflection. BRDF. I always get confused because it's bidirectional reflection distribution function. The bidirectional part is all one word, but yeah, BRDF for sampling the maps and using them in a lighting model. So I'm gonna have to add some lights. I've got quite a lot of existing HLSL code that should just plug in, like GGX or Cook Torrents, and I got some area lights and loads of shadow maps. So I'm hoping I can start to bring all of that together, but essentially in terms of material system, it's going to be a case of bringing in the lighting, and then once I get the lighting working, it'll be a case of thinking about like how to do clustered lighting, I was thinking, or visibility buffer algorithms. So I feel like it's pretty close now, and the lighting is going to be another thing to slot in. So I set up a little sample and I called it light primitives, because what I wanted to do is throw in a bunch of lights and just light this surface, not with normal maps, but just with a normal. And I might put in some models, and then I need to look into transforming the normals on the mesh by rotation. So that's a worthwhile thing to do in here. And then in the material system, it'll be a case of transforming tangent space normal maps to world space and then sampling lighting. So that's the kind of direction where I'm going. And there's a little bit of code here now in the draw thing where we have world buffers, which is a component. The draw buffer, the material buffer, and the light buffer. And then we had instance buffers, instances, and so forth. materials. So materials in the instancing system is still being defined, but these world buffers and buffer component and this parent entity, these are like code which I think I'm gonna, I think I'm going to keep around. Let's have a look at world buffers. Because yeah, we query world buffers in a shader, but world buffers is just there to hold on to this to the memory basically, and it's possible that I think that this one, world buffers, might want to be a PMFX feature and not a component. So that might be a little bit of work to think about. But this is going to have to be visible anyway, to be able to use it in the other sample because it's in a different file. So ECS demos, for now, I'm just going to put this in here. The component of world buffers. And then I'm going to call it, that'll be crate. Well, I can just use it in the file. But I think I'll probably do that off stream. I don't know. I'm trying to keep it like to work on more sort of visual and enjoy, not necessarily enjoyable, but more kind of visual stuff that's a bit more interesting to look at on a stream. Hotline GFX buffer, world buffers. Is that already? It should have been pulled in probably by that. World buffers. Ah, no, it can be there. Oh, right, okay. That's fine then. We are using it across different parts of the package. I've messed this right up. Right. Oh no, so now I do need GFX. Right, all of that to do nothing. So we're going to use draw world buffers essentially, and we're going to do the same kind of thing. What I really need is a way to... Oh, I need a light buffer. Okay, so we've got material data, and we're going to have light data. So the first one, just going to be easy to implement is point light. But light data, yeah, we want a packed light buffer. And then we can use an entity instance position and rotation and stuff like that to set the light up. But we need a packed version to pass to a shader. So it's a vec3f for position. These also, I want to make sure, manually making sure these are going to be aligned to four floats. So that means there's effectively a padding next. And we could use those for something a bit more readable. Typically what I would used to always do is put everything as vec4s, but I'm going to try it this way. So we have a pause. We could have a vec4 color, or I think I want to have lots of lights. So maybe we want to have a U8 color, like one U32 packed. What? I don't even know what the type is. It's 1 byte. No, forget it. I'm just gonna go with a float for color. Color is a vec4. So we've got position and color. And what else do we have? Well, this could be radius. Right. And that, I mean, that's all you need, right? For a point light. So that's the first thing I'm going to do. Just, I'm going to make a forward light shader. I'm going to sample this. I did think here, this grid, there's a bit of Z fighting, and I could use the raster state to good effect there to offset that, the same as how I do with the geometry primitives. And then it just kind of makes it so you can have a coplanar thing. Probably on this demo, to be honest, it might not be desirable to have the grid, but I'm going to get into setting that up. I mean, I set this up already just so I had something. But we've got light data, and I think if you try and create a size of light data, I mean, we don't have any lights, but oh, that's the wrong one. Got material buff. Living in a material buff. We're living in a material buff, and got a light buff as well. Light buff. I don't know if you can hear that. There is a meowing cat. Hi. Not time. 15 minutes. So I'm gonna have to create a light buff of size 1, because a 0 size buffer is not permitted, and that just needs to be to initialize that. We can make it optional, but then it's got to be an option, and you've got to run wrap, and this sometimes it's a lot to think about. We've got material data. We don't want data. I'm just making this empty. It's part of the shader heap. Okay. But in the case of that's a draw buff. So in the case of this demo, where it's just going to be a point light, or well, it's not going to be point light, it's going to be all the kinds of light, basically. And I think I'll do a demo of just lights without shadows, and then I'll do a demo with lights and shadows of each kind of lights as well. Just so there's like separate ones you can go into, and you can kind of then, especially I always think about porting, if I've got a port or add a new platform, just kind of decoupling all of the work, so it's quite easy to just incrementally work on a sample with less going on. So I call them light primitives. I think these files, the way they're organized, I might revisit that and change the kind of the data layout at some point. We have draw buffs. We can have one element. Material buffs. We can have one element. Light buffs. It's going to have lights in it. So how many lights am I going to have? Well, I just want some random lights, and then random lights with random colors. Kind of like I had some other stuff that was randomized. Oh no, I wasn't drawing random colors. I definitely did something else which generated a random color using HSV. What other demos do I have? C-buffer, for instance. Blend States had them. Blend States was doing some randomized colors. So is this compiling? It is compiling. Great. And then primitives, I've got the light primitives, so I'm creating that. I'm not actually instantiating any of those. And like I say, these things, light buffs and all of that, what these really need to do is you want to be able to, during an update, be able to resize these buffers, because you might want to spawn lights on the fly. So you want to be able to have like a stretchy buffer, a dynamically sizing buffer, which can then essentially resize itself and reallocate its resource views and that kind of thing. So that's something I've done in before. I would call it a dynamic buffer type. I would build it on top of this buffer, the abstracted one. I wouldn't build it at the low level because basically if I do it in D3D12, I'd have to do a new dynamic buffer for Vulkan and Metal. And I made that mistake before when I did my C++ engine PM Tech. But in places I've worked at, and I've worked on engines, I've actually solved that problem by having a higher level dynamic buffer and doing more code in the higher level. So you learn from your mistakes. So we can create some buffers and spawn the world buffers, and then we spawn just a simple plane. And that build's failing. World buffers, or all of these. So this is draw. And that's create draw. Maybe just do that. Create draw. This needs a PMFX now to create its heap. Material data. They're in draw. So then draw material data. So yeah, I think in the long run, PMFX would create these ones because we know probably, well, maybe this is a bit more ECS-like, but there would be somewhere where we create these and they would persist. And then you won't have to create them for every sample. You would just always get a world buffers if you want it. The reason I'm thinking PMFX is because it can, let's see, these don't have to be components. Yeah, I think maybe it makes sense there. Then, because they're already passed into render functions, so you would just be able to obtain the world buffers from PMFX and bind them if you want them. And not even that, actually, because we just want to know the index of the light buffer, and we pass that in the push constants. Scratching kitten. What are you doing? Huh, yes, I can see you in the reflection. Right, anyway, so world buffers, does this compile now? Okay. Okay. So then we need a light type basically as well. Oh, we already had a light, didn't I? Light data. But what else do I have? See, now my components are all kind of all over the place. So we have a color component. Have a color component which we can use. We have a scale component. I just need one of these kind of component things to say this is a light or this is a point light. Or an enum, which can be the light type. The light types might be able to pass them through to the shader as well. And I need to think about how to do that. Do I want to store all of the lights in the same buffer with some data which says which kind of light they are, or store all of the point lights, spotlights, and so forth separately? Let's see if we can do. I don't know if I've tried to. Oh yeah, I think this will work. Hub enum. We're going to have a point light, spotlight, and a directional light. So actually, it's worth thinking about directional while I'm here. This is outside of the plugins, so I'm going to have to recompile it. And while I'm here, I just want to look in this. I called it imdraw. It's what draws the grid, which is a Oh, actually, maybe that isn't in there. It's in the core ECS. I have too many files called the same thing. Render grid. Right, so we've got render grid, and it uses imdraw 3D. Great. Okay. What I'm going to do is just have a little look at imdraw 3D. This has the imgui shaders in there as well. It's not setting a raster state, but we have the raster state. Is it in debug? Debug PMFX. Debug PMFX. Okay, so the wireframe overlay had a raster state called wireframe, and that must be in hotline.pmfx. Okay, imdraw.pmfx. So what that does, the wireframe, this one's actually a little bit old school. It does a slight depth bias. This import this should import really, and don't need these. I needed these. It's only minor, but you can use it because it can support JSON, but they're not necessary. So I'm just trying to bring that down. Things inside there, that's looking up names, so they are strings. Although you can have unquoted strings. That doesn't seem like it's worked, to be honest. The imdraw 3D shader. Let's see if this works. Triangle list. Huh. Bit weird. That's definitely not a triangle list. Well, I might make my own raster state. Oh, where did you go? So the depth. Right. I might just make one. Oh, hold up. It's got depth test less on there, but oh yeah, I want to put an extreme depth bias on there. Plus 100. Oh no. Don't know if that even matters. Well, it's a line list. Still looks bad. Oh my. Right, let's see if it's the minus 100. No. So I'm just sidetracked doing nothing here. imdraw 3D depth test less. They're all compiling. So it's missing raster state grid. All of that's kind of picking up errors. Wireframe. Too much Z fighting for me. I think there should already be a depth test less inside hotline. Depth test less. I'm going to try depth test less equal. Hasn't really helped. It doesn't really matter. I can move it, stop it Z fight out. I just thought I could. Hold on, I'm just going to check. I don't know why that's compiling now. Didn't want you to. Because I changed the import, I'm wondering if something had gone weird with that. If that's the correct way I should be doing it now, because I refactored. It allows you to combine and merge in more kind of state from other files. Nah, it still looks terrible. Actually disgusting. Actually disgusting. Hold on. I wonder if the depth biasing doesn't work. Anyway, that's not the point. I'm gonna sort that out, and I might not even draw the grid. Just getting sidetracked there on pointless stuff. I'm just gonna feed the cat. Right, son. Tea time. There you go. Okay. Just ignore it. Just ignore it. Back to what I was doing. Primitive. So I was looking at what components we have, and I want to spawn some random light and some random colors. That was happening in the blend that tests had some R&D gen for it generates a random HSV and random positions actually. So let's just take some of these. I'll just take that code just to give me a head start. I am a copy and paster and no Vim or stuff like that, and mouse user. So make of that what you will. Primitives. We fill that out. We're going to spawn that and ground plane. Spawn, and I'm going to make that lowercase. We don't want meshes. So we're just randomizing position. We don't care about rotation. This is some randomizing alpha. We're just going to randomize the hue. So how many lights do we want? Let's do a number, power of 2 number, power of 2. So 64 lights, should be fairly easy to handle. We'll randomize and what's the range going to be? So let range. So I want to keep them fairly consistent, maybe in the y-axis, but randomized in the xz. So that means it's going to be vec3. And then the size of the plane is 1,000. Probably a bit big, let's say. Well, let's say within 1,000. So it's actually arranged within 2,000, and then you have to minus half the range. To kind of, or add it. 0 to 2,000. No, then you subtract. So, times range. We do times range, and then we multiply, and then we subtract that. So that means pos, well, that's not going to be a randomized number. Let's just say that one's going to be a fixed number. I mean, when it comes to doing these kind of things, I'm not very creative. So 10, depends how big the radiuses are. I think they need to be reasonably big for 64 lights. I feel like I should be going for like 256 lights. Is that a lot? 64 lights. Let's just start small, and I'm going to set them to 64 height. I'm going to make sure that their radius is large enough for them to touch the floor. So we don't want a mesh, we don't want a rotation, or a scale, or a world matrix, or a world component, but we do want that. Technically, the alpha, well, that could be strength or something. And then these are just going to be saturated colors. So I'm just randomizing hue and then converting HSBC, the bank, into RGB. This is randomized lights. It's going to be all point lights. These buffers, I don't want to have to do this all the time, but I'll clean that up when I get a chance. So, what do we need to do now? The lights need to be batched into a matrix. Well, not a matrix, but we need number of elements, which is going to be 64. So let numLights equals 64, and then I can pass that to that function to get the number of elements. So number of elements in the light buffer. I could make the default of world buffers just create these kind of stub ones, but I'll think about how I'm going to manage that a bit more. So there we've got lights, and then they're at 64, so their radius should actually be bigger than that. I'm going to make them a height of 32. So then if their radius is 64 as well, then that's going to intersect the plane. And then, oh, it's a pos. Where's that coming from? Pos. So I don't care about that. I need all of this nonsense. RNG. Rand thread RNG. I think I might need to include all of that. Or use it. Rand prelude. Right. So we've got some randomly generated lights. We don't use the eye. Okay, so now I have some buffers. I need to call a function to batch them together. Like the draw one has it already for different kinds of things. So what else did we do? And these batch world matrix instances, batch material instances. Is that material data? This is going to be batching light instances. These batch functions, these are also going to be things which over time they become a bit more of a core feature. But we only have a position and color, and we have a light type, which is going to be point light. How do we do this? It's not like that. Light type. Is it like this? I'm not sure how I'm supposed to spawn. Oh, I don't think I even need to do anything. I just do that. So I'm a light type point, right? And batch light instances. So the lights might animate. That's something I'm going to do. I'm going to add in the ability to animate the lights. But for the start, technically I don't need to do this. I just need to fill up the light buffer with data. So, I mean, that was just copy and pasted from the other one. So, for quickness and for the sake of getting something working, I think I'll go and I'm just going to fill the data with static light data. So, num lights, and then they are instances. light data. I'm gonna make that a vet, and then we can just push back light data of pos. We already have a pos. That's going to be of moved, is it? I know it can copy. Color. Move that. Color col. And then what else do we need? Light data. Radius. So radius is going to be, I said it was going to be 64. Not mutable. I like to put the mutable and not mutable stuff together just to be organized. Right, we're fine. So we've got light data. This is just static data. And then I can set up the shader, get that working, and then do something more fun with it. I really should maybe set up some nice demos. The idea was always, I want this live coding to do stuff. I have done some little demos in the past of like geometric kind of animations, but I'm not, to be honest, when it comes down to it, I'm not that creative. I just kind of, I know where I stand with like getting the features working, you know. So num lights and lights data. I mean, we can initialize that. We can even use light data dot len in here. Right, so now where are we? We've got the lights into buffers and ready to be used. We spawn world buffers, light buffers, etc. That can be bound in a draw call. I might be able to do this with the latest render function I was using for the material sample. But what I essentially need is to change this mesh debug render graph to one that's going to accept lighting. And at the same time, also, let's have a look at the ECS demos render functions. So if I use render meshes bindless material, we push in the buffers. So we're going to have world buffers light as the next one. So we want this. Instance buffer. Instance draw query. Instance batch. I mean, that's fine. I think I'll just sort that out. So we'll basically you can start using the same. I mean, even that, this might change, but this shader's already doing a bunch of stuff and I don't want to have to add a new variation of it. If anything, I want to start consolidating these variations and I want to have less. And I want to make the code a bit more easy to follow so it's clear like this is how you set things up and this is how it all works. So yeah, we do have a mesh component, but we don't have an instance buffer on this guy. That's all. and we do have world buffers. So we can change the pipeline, and it's a per pass render pipeline. That's all fine. So basically, I may as well throw in some more meshes, and let's see about mesh debug. So debug PMFX, we've got mesh debug, we've got mesh material. What do we dare call it? Mesh material instance DBG. That must be like not even used, right? I'm just gonna double check that. There they all are. Now, beautiful materials. Is it all working? Draw index, geometry primitives. Where was I? Light primitives. Okay, so I'm gonna add some more materials to that. I don't want them to be. My intention wasn't to have a materialed mesh. I just want to have a plain one that's lit, and then you can kind of decouple issues. So I'm not indirectly looking up textures and lights and everything. There's separate ones of each of those, and then I can go and combine those in a sample. Maybe that's overkill, but it's sort of just the way that I end up working. Mesh material instanced. So it's kind of one of these. Mesh material instanced. It's very similar, but we want to have that. We don't need a sampler. Buffer IDs, push constants. We do want mesh lit mesh lit, and it's not going to need samplers, but it is going to be instance. Another thing you can do, we could make one draw call which does instanced and single meshes and just loops over the two. So, but maybe it makes sense to throw in a few more. So I'll just leave this for now. VS mesh material. I think that probably could be okay. Buffer IDs, PS mesh, lit. So the mesh material passes through indices and it passes through chords and everything. That's kind of stuff that we're going to need. Mesh lit instanced, and that's going to be very similar. Grid meshes, but this is going to be slightly different. And at this point, pipelines, render meshes, bindless material. That might become more generic. It depends on the grid. I'm thinking I might just say, let's not draw a grid. This one, they're going to be lit and like lit by lights, not lit like the slang. I don't use that word. PS mesh lit. PS mesh lit. It's going to go in here. PS mesh lit. And for the start, of this output color. I'm going to just hard code it. I don't know what color I feel like doing today. I'm going to make it orange. That should at least get that to compile. So now let's go with mesh lit instanced in from the primitives sample. So render graph is going to be mesh lit instance. There's going to be no grid. There's going to be no meshes when this builds. Oh, it's not even drawing anything. It's making no draw calls. I'm just trying to move around and nothing's happening. So that means the clear is not happening, but I think it's just because we don't have any meshes. So the ground plane, I mean, that's just going to be his own instance, right? Let's see if we can get bindless. I'm going to try and get this one back. Lib. So yeah, like I said, we could have a mesh component without an instance buffer, right? So just a mesh component explicitly without the instance buffer. So this is another query. Ooh, how many things do we need? A query, that's not a tuple anymore. Yep, that needs just that. Okay. So render meshes, bindless material. Now, this is starting to become not really render meshes bindless material, but instead a very generic render function that can kind of be dispatched to do, you know, quite a few things we might need it to do. My last engine, my C++ one, I had like, you know, kind of a core render function which could do everything quite generically, and you don't need that much code because you're just binding a few buffers. If you have some conventions, so the same draw call was used, or the same render function was used for shadow maps or for normal passes, and then the kind of the view sets it up, and that's what I'm hoping for here. But we just need to have a way of knowing how to dispatch single draw calls versus instance draw calls. And render meshes bindless material. It's not necessarily material. I'm just going to call it render meshes bindless, I think. So we've got another query, instance draw query, single draw query. That should compile and not really make any difference for the time being. Single draw query is unused. Let me just get that there. I'm just making sure my camera is orientated. So light primitives isn't doing anything. It's not complaining. It's got a render graph. It doesn't render anything in here. But I still expect the buffer to be cleared. I was expecting the buffer to be cleared to grey. So I'm not quite sure why that is. But instance batch draw calls and then single draw calls. which this is feels good already. Even even just setting this up now, I've got a more versatile render function, and I would like to not have to be registering different example render functions. Move the example render functions into example files so they're grouped together with the code they belong to if they are a specific, bespoke, more direct example. And then these kind of ones, generic ones, moves into the core ECS, and this is what you would use, and you wouldn't really have to worry about this that much as an end user. I'm worrying about it because I want to sort of really have a look at the fine details, but we don't have an instance batch. We just have a mesh in a single draw query where we go mesh, mesh. We don't set that index buffer, and we set that to 1, and that's a draw call. So now do we draw something? No. Let's have a look. So we change to draw material. Draw material is still working, and that uses this newly changed render meshes bindless material function. And then the light primitives should be calling the same one, so we set up a light primitives. We render meshes bindless material, and that's all we're doing. We are calling it. Let's have a look. The meshes pipelines meshlet instance. There's no errors. Program's still responsive. There's nothing coming out here, is there? Creating graph view meshes for main view, no clear. Which is, I know what it is. We're going into main view, not no clear, but because we're not going into a grid, we actually do want to clear. No, it's still not working. Let me put the grid on. This is why the grid is handy. Right, there's that. Right, okay, so now I'm rendering, right, and I've got two things. I've got render grid and render meshes bindless material. Let me just double check the shader's not. The next thing to check. Mesh lit instanced. So it doesn't necessarily, the view doesn't necessarily have to be instanced. I'm going to call that mesh lit. I'm going to call this mesh material, because they could have a single material or an instance material. The instance pipeline makes sense. So we've got mesh material and mesh lit. Render graph mesh lit instanced. So that's still referencing an old render graph. I've been trying to tidy this up, but there's some quite complex, well, not complex, but it's much harder than it sort of sounds. So in the primitive sample, that's just going to be called mesh lit. Mesh lit, render meshes, bindless material. Okay. And then in the, I'm just going to quickly restart this so it's a bit a bit clearer. So light primitives is fine. Draw material is going to be missing. Mesh material instance is missing, and that's in the draw samples. So again, with these the samples, the way they're grouped, I think I'll tidy that up, and I think I'll move things into separate files. But the material, the render graph is mesh material. Okay, so there we're back. We're rendering things in there, and go to light primitives. We're just not rendering anything, so this is where this comes in handy. Single draw query, mesh component without draw instance buffer. Right. I can just print in here a draw call. Draw call exclamation mark. My neck is killing me. Right, I'm making a draw call in there, which is weird. Well, not weird, that's actually correct, but set the index buffer, set the vertex buffer, draw, indexed, instanced, number indices for one instance. Ah, I know what it is. I'm looking up the world matrix from an instance buffer, not from however my other shader is doing it. So in those cases, I do need a different fragment shader. So there would be a mesh lit instanced. Debug.hlsl. Let's go. So when I'm doing draw call lookup, we don't have any entity input, which we do have on draw call. So VS mesh IDs, albedo, normal, roughness. I think it just makes more sense at this point. I don't actually need the maps. I'm tying myself in knots just thinking about this. So this is fine. I'm going to just change that shader. The lit shader is going to be that. PS mesh lit. Mesh lit and VS mesh. Viewpoints push constants, buffer IDs push constants. Because I need to know what the world buffer is. The light buffer. Entities, materials, and lights. So I actually need to add one in here. And then I wondered about having one of these per light type, like for spotlights or having them all packed in one. But for now, I'm just going to do this. Material data. Buffer IDs are going to be pushed through. But what I actually need, I need C buffer instance, buffer IDs push constants, which is those. But I need a I need view push constants, which is fine. We've got view push constants, we've got draw push constants, and then buffer IDs are overlapping. It's a bit of a juggling act here. But we're going to go with light data. And that's got basically, was it float 3 position. Did I call it position or pos? Radius. That's all I had for now. Right. Now line that. So we've got lights. C buffer instance can be on the buffer IDs push constants. I'm going to push up to 2 because I need these as well as, let's see, well, the single draw call. So here we set the push constants of the view projection matrix, which we want that. Then we set the push constants of slot 1, which is the buffer IDs. And I need to request the slot for that in this similar way. This is going to be fine, but then and so my render meshes, we just want to do one of these, right? So that makes sense. That goes on slot 1, but it might not be slot 1, and that one might not be slot 1. They are going to change. So 0 is view, slot B1 is draw push constants, and slot B2 is buffer IDs. This C buffer instance data, yeah, that's it. That's moved to test, because that's just a very basic test that can kind of make sure C buffer's working and we can index into it. It's not a very good example, but so this one goes on B2 and S0. Single draw call. I mean, at this point, we're not using these buffers, so I don't actually need those buffer IDs. And it should be setting those on the right one, so I hadn't saved this. Mesh lit mesh lit is not instanced. We have view push constants, buffer ID push constants, and draw push constants. So 3 sets of push constants. View draw 0, 1, 2. Mesh lit is just not instanced anymore. That's compiled with nothing happening. Great. So the wheel matrix goes into slot 1. Maybe it's expecting it to be in slot 2. Ah, I hadn't saved that. And that needs a mesh component and a world matrix. So that's going to have to change. Mesh and world matrix. And that needs to be updated in here. The reference. So, oh my god, this has hung my whole machine. Right, the problem with that is then, well, crashing and GPU hanging is it's going to mess up the stream because the hardware is still doing stuff. And so this is what was happening the other day as well. I don't know if my audio might be out of sync with the video now and that kind of thing, but here we are. This is going to probably be a common thing that happens. So this is what was happening the other day, and this is the old thing I added last week where I can now get the D3D validation messages. So PMFX will remove things that aren't present in a shader, and what I need to do now is query it in the render function. In the ECS demos lib. So we can request like which slot is push constants like this basically. And we know this is going to be on slot 2 register, right? It's on register, and the descriptor type is push constants. And if there's a slot, we put that on, and we bind that slot. This allows the shaders to be a bit more reused, and slot. Okay. Set the buffer push constant. And so you might do a batch of drawing over these with different pipelines, and some pipelines that might not need to set these at all. So that was, it said it only defined 1, but it should be using the slot 12 world matrix 0. Set the world matrix push constants, right? Clear. Let's just check the shaders compile, and let's just check the actual output of, it's called debug JSON. Okay, mesh lit, right? And this is untextured lit. Get stencil state, vertex layout, descriptor layout. So there's 2 lots on there. We have shader register 0, and that's view push constants. And I put these names in, which has made it very nice. And then we have draw push constants on shader register 1. So what it was trying to do was it trying to bind the buffer IDs incorrectly. So that's to be expected. Shader register 1, we bind that on slot 1, and we bind that on slot 2. Someone's scratching upstairs. Annoying. Oh, it's got an orange floor. So, right. We've got an orange floor. We now have a more resilient render function which can change the slots that need to be binded to either push constants or heaps, and that's the thing that's been mostly caused me trouble. I've got a lovely orange hue shining on my face now. Right, PM effect. No, what is it? I don't know if that background noise is audible, but I don't even know what they're doing. Idiots. Set the world matrix push constants and set the buffer IDs push constants. So what I essentially want to do now is bring in the buffer ID into the shader, which is going to be the light buffer. And we filled the light buffer full of random data. Now I'm not going to do a lighting equation just yet. I'm just going to go a little bit at a time. So what have we got? We've got buffer IDs. How do they work? They're push constants. Buffer IDs push constants, and light buffer. If buffer IDs constants light buffer is not equal to 0, I'm going to output a different color. Oh, yes, pushing the boat out. Let's go and let's flip this. This is going to be purple, is it? Purple. Is that, I'm in the wrong. Hold on. And let me boot it from there so I can get, it's failing. I'm in a world of confusion when it comes to if statements. Go switching between Rust, C++, and Python. How do I like them? I think I like them like this. Book white space. I don't need it. I don't need you. Minimize all that white space. Right. LPM effects. All just all and run. It wasn't purple, it's blue. Is it this? Ah, no, this would be purple. That's gone to orange. Hold on. Lights buffer is not equal to 0. Cyan? Right, it's gone to cyan there, but then 0.5. It does not like that. Just 0.5 in the red axis. Well, I think it was working. Right, what I wanted to do is this going to be purple? That is purple. Anyway, I think this is right, but I'm not sure. Buffer. Buffer IDs. Buffer IDs, let's see. Let's get it to be the precise value. Buffer IDs 3. And let's make sure we're pushing them. I'm trying to concentrate here and just not let the upstairs neighbours weird scratching get to me, but I'm not gonna lie, it's not the easiest. Buffer IDs .z. Okay, light buffer ID. Light buffer ID is 2, right? Light buffer ID is 2. So if we're going to check if it's actually equal to 2, and that makes that dark kind of red, or we make it 0.5. At some point, maybe light buffer ID had become 0. Light buffer ID is 0. That might be. It might be okay. It might actually be 0. Which is fine. I feel like it shouldn't be 0, but I'm going to have to just... If I compile this again, does it change? Light buffer ID is 2. So what we're doing is we're rotating between. So anyway, that's fine. I think it's working. The trick is maybe I should always allocate 0 as a buffer, like the first thing in a heap is a null. You know, then you can genuinely use that trick to know if something's happening. But I think I've got a light buffer, right? So I was checking. I checked it against the thing. It's passed me in the light buffer. I know which index the light buffer is. So what we can do now is we can sample from the light buffer and just take the first color from the light buffer. And if this works, then we're going to be laughing. So light buffer ID. Let's grab that into a uint lights ID. Lights at lights ID. Oh, dot color. Lights ID 0 dot color. So we're gonna choose the first light, the first light's color, and it's kind of a green. and then a yellow, and then a purple. Perfect. Look at this. We're going through all the colours. I was doing it manually before. Right. Fantastic. So they're the light colours. The light colours are correct. We're getting there. Right. So what I'm going to do now is steal some of my prior work. Or should I try and just do it off the top of my head? Let's see. So I think it'll be fun at least to do Lambert. Lambert's easy. I could possibly remember how to do a Fong or Blin, one of them. Maybe it might be fun. I think I'm going to need more data actually in the view constants for doing specular, but let's do off the top of my head how to do lighting. So how do we do lighting? We've got float 3. Does VS output have world pause? Yes. So currently a meowing cat. What? Come here. Come here and do something cute. No. No, he's not having it. Right. Okay, it's getting towards that time where I become tired. 1 hour 45 is like the sweet spot, maybe sometimes going up to 2 hours. Let's try and just get a diffuse Lambertian or Lambertian diffuse of the lights working, and then I'll be more prepared for next time for specular. I've got existing code that I can bring across, so this should hopefully go more quickly, and I can start to think about how to consolidate these render functions and that kind of thing. So let's go. So what do? We take a vector from everything's in world space. So we take a dot product essentially, and then how do we do attenuation? Can't remember. Linear fall off. N dot L. I think we just do N dot L, and then that's just directional. Oh, and then, well, we can figure that out. Either some kind of attenuation. Input world pause. You take the direction from the world pause to the light. So that's the light pause. So something about lights. I don't know how. There was a few, weren't there? There was. Did I make 64? And here we go. Same again, doing Rust style loops. I less than 64. So need a way to know how many lights are in the buffer. That's going to be some extra data. Let's make a note of that there. To do. Need to know the num of lights. So that's starting to become more push constants, or there might be uniform or like constant data that all of the fragment shader quads are going to read. Light data equals light data dot I. And then input world pause. So this is it called light data? Light data L. So we can do L dot pos minus this is L in the old n dot L equation. Flow n we already have. Float n dot L going to be dot of input normal and L, and then we need some sort of, let's initialize output color to black. Actually, you want to output 1 in the alpha. So there. So then I'm not sure about how you do the attenuation on the radius. So this would just give us directional light. Let's accumulate it. Color. Plus equals la L dot color times. Well, I could do some hack, but there's like a nicer fall off. Linear fall off with a power. L dot color times n dot L. That's failed. What have I done? I've got two L's. That's why. Light data. Data. I'll call that LD. LD, pos, and LD. No, that's just L. And that's LD color. It's going to be, black. It's just black. Let's try and flip this around. No. Well, that was embarrassing. Can't even do n.l, mate. I can't even do n.l Lambert diffuse. I said it was going to be easy. Right. World pause. Let's see. Let's debug this. I know we can divide it by 1,000 because the thing is 1,000, and we can do output color equals world pos divided by 1,000. Now we can times 0.5 plus 0.5. This should give us some sort of color data, right? That looks to me like world positions. So world pos is correct, and that's fine. Let's check about lights. Let's go with LD0. Position. LP, right? Dot pos. That's failed. Float 4. Right, that looks, that it's one position for each thing, and it's going to change slightly. Yep. Right, so the light positions look like light positions to me, and they also look like light colors to me. We don't need to multiply it by that. I'm just going to plus equals n dot l, maybe. Color plus equals n dot l. N dot l. Is it like 1 minus n dot l? Right, we've got some n dot l's in there now. Obviously, there's going to be tons of light because there's loads of them. So we need to attenuate them in some basic way. But that was the mistake, right? It's 1 minus n dot l. LD dot color plus times n dot l. It's just that. And then let's just do one light. Okay. Not really much to go on. So instead of normalizing this is going to give us a value. This is light. I'll start calling these a bit more better names, and then this can be called float 3L. It's the normalized version of that, of to light. And then float mag equals the length of the light. And then I can scale the n dot l by the magnitude. That hasn't worked. Line will pos minus pos mag. Mag. And that needs to be scaled by the radius. So come on, scale by ld dot radius, and then this needs to be map saturated because it might go to 0. Still too bright. How did mag make it go yellow? Oh, yellow is the color. Yellow's the color. Probably embarrassing myself at this point. So we've got length to light divided by the radius divided by the length to the light. Then do we invert it? So 64, say if it's the distance is 64, because that's, no, were they 32? They were 32 high. So if they're just above the plane at 32 high, the distance to the light is 32 units, and the radius is 64. So at that point, we should be 32 divided by 6. 32 divided by 64 is 0.5, which is length divided by radius. Right, saturate. Then we could do 1 minus. What the hell? This is crazy. This doesn't make sense. Hold on. In the distance, I'm going to take off the grid. Draw here, PMFX, get rid of the grid. It's just the grid making it look dark. This can go straight into main view. No, it can't. I can't even do that. For some reason, I'm relying on this. Right, each time it reloads, it generates new colors. So that might be causing a bit of confusion. Hold up. Right, oh, okay. There's the kind of thing, right? Right. So that's sort of what I was trying to do with the attenuation. Which kind of looks sort of how I wanted it to. And the only problem is then it's like, why is the colour? This needs saturating. Or is one of these not normalized? That's normalized. Input normal. Is that normalized? N.L is definitely wrong. LD dot color. Right, okay, there's colors. So it's just N.L now is this one, the dots. This also needs to be saturated. And I think it's because of the 1 minus. I'm not sure how many saturates I need. Right, reload complete. Well, that's it. There you go. That wasn't probably the most impressive, but I got some basic lights. I have existing shaders, and I've already done all of this nonsense before. I know nonsense. It's actually quite good, but I really like it. I just didn't do it very well. I'm going to leave it there. I think that's a kind of a decent place to leave it. Don't know why the grid thing wasn't working. Render function, render grid. This goes into main view. Oh, there we go. Right, now I've got rid of it. These have got little halos around them. So N.L. Does this? No. Not very nice, the overlapping and the like little lips on there. Mag. I wonder if that needs it. 1 minus. Saturate that. I think that's going to be the mag. I don't know if it needs the mag anymore. N.L. No, it does. It definitely needs the mag. Oh, That looks interesting. Anyway, I'm just fiddling now. So that's the end. And it's kind of lighting.